equation and substitute. So you could do sine minus 1 x minus 2 is equal to t.
You might think that, but I think you lose half the information if you do that.
Oh.
Have an idea. What if you squared both sides? So let's say, what if we did x minus 2 squared is equal to sine squared t?
Yeah.
Could you do something similar for the y one?
Y plus 3 squared is equal to cos squared t.
And now is there some way that you can bring those two together?
Oh, sine squared plus cos squared is equal to 1.
And so you could do...
So you can just add them.
Yeah, GCSE simultaneous equations.
And equal to 1.
And so x minus 2 squared. What type of... Okay, and graph?
Quadratic?
Nope. How could you graph it?
Plot the points.
Yeah, you could plot a few points. You could plot when x is 2, what is y?
Oh, it's a circle.
I think it's an ellipse, so it's similar to a circle. Maybe it's a circle. Let's take a look. Yeah, it is a circle. That's it.
Yeah.
So it's a circle. 2 minus 3. So its center is 2 minus 3. What's its radius?
1.
And
no, 1. Sorry.
What is the square root of 1?
1.
There you go. And its radius is 1. That's it. Radius equals 1. So yeah, x plus a squared plus y plus b squared equals r squared. That's stuff. If you had brought them together as arcsine, cosine, that stuff, you only get half of the graph, I think. Any questions there?
No.
Okay. Hang on, what did Bookie say? That thing. Alright. They just assume we understand this stuff. But, okay, how about this?
So you do the same thing. So you do x squared is equal to sine squared t. And then y squared is equal to sine squared 2t. I don't know what you do next.
What's this 2t about?
Double. Don't know.
Double angle formulae?
Oh, it is double angle. Okay.
What's sine 2t the same as?
I can look it up.
It is equal to 2 sine t cos t, I believe.
Okay.
Is your microphone near something that keeps like going whoosh, whoosh, whoosh all the time?
No.
You genius, man. Alright, go on.
So it's 2 sine squared t cos squared t.
I think it's 4 sine squared t cos squared t.
Well, I'm not sure if you can add them together. Oh wait, no, you can't. You can't add them. Okay. You'd have x squared plus y squared is equal to 4 sine squared t cos squared t plus sine squared t. But that doesn't have 1, so I don't know.
Yeah, I was thinking you could sub one into the other, like 4x squared cos squared t.
Oh yeah, that makes sense.
Well, it still has a t in it, and it's not supposed to. Cos squared t. What can we do about this t?
For the cos squared t, you can just do like 1 minus x squared.
Ah, yeah, that's 1 minus sine squared. Yes.
And then you could just expand it.
Let's not expand it. Let's just leave it like that. 4x squared 1 minus, and sine squared t was x squared. Great. That worked out.
Range. Oh no.
Stating the value of the constant k. Where are they getting this constant k from? Oh, I cut it out.
It's like what the x is, I think.
X is between minus k and plus k.
You just have to find like the sine of minus pi over 2, and then yeah, I think.
Oh, yeah, sorry. T is between negative pi
It's
over
just
2 and pi over 2.
minus 1, I think. Yeah.
What is it?
Minus 1 and 1.
So x is between minus 1 and 1?
Yeah. So k is 1, basically.
Okay. Stating the value of the constant k equals 1. We'll take your word for that. And B.
Wouldn't that just be sine? Wait, that's. Oh wait, okay. It would just be like sine minus pi, and then
Yeah.
sine pi. So it's 0.
Are they both 0?
Yeah.
What's this going to look like? So t is between those two.
Yeah.
So y is going to be between sine 2 pi over 2 and sine 2 minus pi over 2.
They're both 0.
So sine of pi is 0. Sine of minus pi is also 0. But what does that look like in between those two?
It's a trig graph, so
Yeah.
yeah.
So what does the sine graph look like between sine? Yeah, what does the sine graph look like between pi and minus pi?
It goes through like one whole cycle. I don't really know how to explain it, but
What's its range?
-1 to 1.
Yeah, so I believe the range is going to be -1 to 1.
How is that the same as the domain?
-1, 1. Maybe I'm wrong. Why? The domain for this. What's the domain?
That the minus kx k, isn't that the domain?
The domain. Oh, sorry. So the domain is going to be what? Minus pi to pi?
I thought it was -1 to 1.
I wasn't sure where you got that one from. Let's take a look. So k is 1.
Oh, yeah, they're both the same.
They are the same. Yeah. I suppose it's a little different. K is 1. All right. And yeah, so the range for the y, although they're both 0, it's in between those two when it goes, the sine graph goes up and down. So sine 2t, we used 2 sine t cos t. Squared them both, sub in. Tricky stuff. Any questions there?
No. I just need to like learn the formula.
Do they give you the double angle formulae?
I think they give you
They give you the addition angle formulae, don't they?
the addition ones, but not double angle.
You could just sub it into that, because sine 2t is the same as sine t plus t.
Oh yeah, that's true. Oh no, this is more identities. You square them again?
Hang on. Yeah, okay.
Or do you just square the x one? Because wait, no, isn't there an identity with cot and cosec? I don't remember what it is.
There is. I can never remember them either, so I always just have to do sine squared x plus cos squared x is 1. And how can we get cot or cosec?
Cosec is 1 over cos, or 1 over cos squared if it's cosec squared.
1 over sine squared, isn't it?
Oh yeah, right.
So we could divide everything by sine squared x?
Yeah. So that's 1 plus cot equals cosec.
So 1 plus
Cot squared
cot
x.
squared x gives us cosec squared x.
Makes it easier, but I don't think it's... Well, you should definitely square the x1, because that only has cot and not cot squared.
And what would you get?
So x minus 2 squared is equal to cot squared t.
Yeah, I think it's easier to bring the 2.
Y plus 2 is equal to cosec squared t.
Yeah.
So then 1 plus x minus 2 squared is equal to y plus 2.
Is equal to y plus 2. Say it again, sorry. 1 plus, aha.
It's minus 2 squared.
So 1 y plus 2 is equal to 1 plus cot squared x.
Wouldn't it be x minus 2 squared? Not cot squared x.
Hang on. Say it again. Y plus 2 equals
1 plus x minus 2 in brackets squared.
okay, so you're doing it all in one go.
State them.
Cot squared. Cot is that. And that's it, is it? Oh no.
Yeah.
Well, in the form y equals
Domain. Oh. Then you just minus 2 and then you have minus x minus 2 squared minus 1.
Yeah.
And I didn't like that.
And you could always fully expand if you wanted to, hence sketch the curve.
Oh, it says state the domain of x, for which the curve is defined.
So state the domain.
Two, and then I'm not sure like what the upper limit would be.
Graph. We shall graph 1 over tan x. Draw. Ooh, shift. Zoom. Auto. That's not right. Shift, zoom.
You can just do view window and then trig.
Shift, view window, trig. I'm glad you're here. Draw. Okay. So. Are you sure it's 2?
No.
How did you get 2?
I put it in, you know that equation cot t plus 2?
Yeah.
Wait, domain is x, right?
Yeah. So you put in cot 0 plus 2?
Yeah.
Okay.
I think cot 0 is 0.
Why are you thinking? I told you
I
never.
tried it. Wait,
You tried it in your calculator, but it didn't work.
I didn't do cot. I did 1 over tan t is equal to 0, but I don't know what that gives you.
So 1 over tan 0. Can't do it. Why not?
Because tan 0 is 0.
Yes, you're dividing by 0. Take a look at our graph. So, so how could you? What would you say for that then?
I don't know.
So for that bit there, so if it could be anything, it'd be x is an element of the real numbers. For this bit here, if this is pi, then x is greater than 0.
Yeah.
But let me think about this. What do you get when you sub in pi?
You get like, it's like a decimal.
Are you in degrees?
No, I'm in radians.
Angle unit. Radian. Math error.
How? Oh, I didn't do 1 over tan pi. I did tan to the minus 1 over pi. I don't know if that's right.
Does that mean tan pi is 0?
I don't know.
Yep.
Yeah, math error.
So tan pi is 0.
It's also 0.
And so does that mean that, let's see. So it goes 1 full.
Yeah, so it's just above 0 and whatever the like top upper range is, but I don't know what that is. What's the maximum value?
So it's basically infinity. But does it go down to negative infinity?
But if it stops at pi, then it's not going negative. So I think
X
it's
is
just greater than 0.
okay. And B, hence sketch the curve.
It's
Again.
another circle.
Oh yeah, sorry. Hence sketch the curve of this one, is it? No, it's going to be a quadratic, isn't it?
Circle. Yeah, it's a quadratic. Sorry.
So it's going to be a quadratic.
Squared circle.
There we go. They just expanded it, did it that way.
It's just x is all real numbers.
X is an element of the real numbers. That is because it includes down there. So I didn't zoom in, but it includes down there. So x is an element of the real numbers.
Down there if it's only 0 to pi.
Say it again, sorry.
Why does it include like the negative part if it's only 0 to pi?
So I can't really zoom in on that one. Let's try with table of values. So 9 table. F of x is 1 over tan x plus 2. So we're going to start with 0. We're going to end with pi. And I'm going to go up in steps of 0.1 pi. Okay, so 5, 3, 2, 2, 1, 0. So yeah, it goes to minus.
How? Oh, there. Okay.
Yeah, so if we kept going, it would go. If I press equals, yeah, so it flips down to negative infinity.
Okay.
Okay. Any questions about that?
No, it's a bit hard. Like green. But I don't have any issues with the parameters.
Yeah, domain and range seems to be the tricky thing. Okay, sec squared 2t. Wow, it's getting real. Let's try this.
Is there an identity between those two? I'm not sure if there is.
Cot and sec.
Also, I don't think you need. I mean, do you square them? Because the trig identities are all v squared.
Mm-hmm.
You square it again.
Oh, what was our thing again? 1 plus cot squared x equals cosec squared x.
Not helpful.
So what do we do here?
I don't know.
Let me see.
They're both 2t. So there's probably a double angle formula.
Okay.
Yeah, I don't know what it would be, but
let's see. So this is going to be sec squared is 1 over cos squared. So that's going to be 5 over cos squared 2t. That's the same as cos 2t all squared. Cos 2t can be written a few different ways.
Yeah, it's got 3 different ways.
And then cot is the same as cos over sine.
Yeah.
Cos 2t over sine 2t. And that's all squared. We could make cos 2t the subject. Would that be any good? Cos 2t squared the subject.
I think I would just make it harder.
Okay. Let's see. We want to eliminate the t, so we could use the identities. Sine 2t.
I think you can just make the cos 2t into something else. 1 minus 2 sine squared t.
1 minus 2 sine squared t. Okay.
I don't know if there's a specific one you should use, but I don't know.
Sine squared t. That's over 2
sine of x.
Cos t. So that's the whole thing squared.
I don't know if that just made it longer, but
so we can. No, we can't. Oh, we could yeah. Let's just see if we did this other side. We could do 1. So 5 over x is cos 2t squared, and so we could sub 5 over x in there. I don't know. Let's take a look. Oh, they're just giving us the answer. Y equals 10 over x minus 5.
where did that come from?
So x minus 5 sec squared 2t. I don't see. Let's try part B. Range of possible values of x for the given domain of t.
that would be 5 to 5 root 2.
So in between 5 and 5 root 2.
Wait, this is the y one, right?
No, in terms of x.
No, wait, it says the range of x.
Expressing, yeah,
It's
x.
x. So 5 to 5 root 2.
5 to 5 root 2.
Oh, I think I did it wrong. Never mind.
Are you sure?
It's 5, but root 2 one is wrong. Because I didn't do 2t. That's a math error.
Let's see. I want to see if there's some graphical way to do this easily.
Why would cos have
sec squared? It's 1 over cos. So at some point, cos becomes we'll have a y coordinate of 0, and so 1 over it will go to infinity. It's got those U shapes on either side.
No, this is cot.
Cot? No. We're doing the sec squared one. Oh, what are you doing?
Cot.
You should be looking at the x. Did you sub it into the x?
Yeah, I did. I was just saying that the graph on the calculator was cot.
Oh, okay, yeah, that was the previous one. Cos cos 2, I'll just say x close squared. So that is 5 sec squared 2t. Yeah, that's it. Draw. Shift. Who knows?
Okay.
Aha. So, what is the range?
X is 0 to like infinity.
How could you express that?
X is all real numbers but greater than 0.
And that means x is greater than 0. I think, though, is it x is greater than... Yeah, x is greater than 0.
Wouldn't it be x is all real? Why would it not be all... Wait, real numbers is negative included, right?
Yep. Can it be minus 1?
No.
No, can't be that one. This identity, we're going to have to take a look at that sometime. It's a connection between sec and cot. Who knows? Okay, how about this one?
I don't think you would need to square them. Obviously, sec is 1 over cos, so could you like substitute that?
Mm-hmm.
So y equals 1/4 1 over cos squared t.
Yeah.
So it's just y is equal to 1 over 4 cos squared t. Yeah. And then you could square the x one. So x squared is equal to 64 cos squared t. Not really helpful, but
I'm gonna make my life easy and say x over 8 squared.
Yeah, that's easier.
I don't always hear what you're saying. I think when you write is like scratches against whatever your microphone is. Or
I don't know.
Alright. That is cos squared t.
So then you could just do y is equal to 1 over 4 times x over 8 squared.
Yep.
Which you somehow... Oh, and then you can just, like, bring it to the other side.
Yeah. Say x squared
Over
over 64.
Oh, you can cancel the 4 and the 64 just to make life easier.
Uh-huh.
And then you can just bring x squared over 16 to the other side.
You can.
You can do 1 over y equals x squared over 16.
Then
that would just make life weird. So
yeah.
that would be good.
Or keep, change, flip. I believe it's 16 over x squared. That's it.
Yeah.
And B.
Sketch on the appropriate domain. Well, it's a quadratic, I think.
Reciprocal quadratic.
I don't know what that is.
So what does y equals 1 over x look like?
Oh, it's like that one. It goes like that.
What does y equals 1 over x squared look like?
The same, but just like further away from the axes.
Nope.
No.
I believe, I think it's going to look like that.
Oh, I don't know. Never seen one before.
And so I think that's what it's going to look like.
Oh, but just like really far away from the axes.
Not really far away.
But it's 16. Is that not?
It's difficult to show them. Like the 16 one, you just do it like that.
Okay.
Domain.
That's 8 times this. Oh, wouldn't it just be minus 8 to 8?
From minus 8 to 8. 0 to 8. 0 to 8. So is cos minus pi over 2 is 0, is it?
Yeah.
Okay. So that should be from 0. So I only need half of my graph.
Okay.
So something like that. Oh, let's not delete it. It was so nice. Okay. So then that's all we need there. Up to 8. Is that correct? Looks correct. And that's the graph they're showing there. Any questions with that?
No, that one wasn't that bad.
That was alright. Let's see, this one, sine t cos t. What the malarkey is this thing?
No idea.
Alright, let's try it. Any idea how you do this?
No, because you can't really square them.
So I think it might be addition angle formula.
Oh, because it's t plus pi over 3.
Do you remember what that would be?
Well, I know it's minus.
I think it's cos t.
Something. Yeah.
Like cos A, cos B minus sine A, sine B. I think that's what it is. Right. What is next?
Substitute x over 2 is sine t.
X over 2 is sine t. Sine x over 2. Okay.
So pi x I don't know if you should multiply them or not, but or you could just work out what sine pi over 3 is, and then
Correct.
root 3 over 2.
So,
So that would be root 3x over 4.
So that is...
Then work out what cos pi over 3 is, which is half.
And so y equals a half cos t.
T. Oh, we have to get rid of the t.
Cos t.
Wouldn't it just be 1 minus x squared?
1 minus x squared is cos t. How'd you get that?
Oh, root 1 minus x squared. Because x is sine t. So the square root of 1 minus sine squared should be cos squared.
Okay.
Sorry, it should just be cos.
So cos squared t would be 1 minus sine squared t.
And then if you just square root both sides, you get cos.
Okay, but what is sine squared t?
X squared. I know what that means. What is sine squared t?
Make sine t the subject.
Oh, x over 2 squared.
So that's going to be x over 2 squared. And so cos squared t is 1 over 2 root 1 minus, let's say x squared over 4. Oh, I see something. Well, I see nothing, honestly. Okay, root 3 over 4 x.
And then I think they like times through by 4 because they got rid of the denominator. But 4 times a half would give you 2, so I don't know where that came from.
Okay, so if we times everything, that becomes a 2. That's that. 1 minus...
And that's 4 minus x squared. Wouldn't that be?
No, you're just making it fit what you want it to fit.
Okay, never mind. I don't know how to make that 4 minus x squared then. Also, I don't know where the 2, what happens to the 2, because there shouldn't be a 2 there.
Did they do something where from what was in here, they factorized out a quarter? That's snaky. So if you have 1 minus
That is
x squared over 4, it's like...
But then wouldn't the half and the quarter multiply? And then you'd have like an eighth.
So a quarter times 4 gives you 1. And so that just becomes x squared.
Yeah.
And so you then have 2 times a quarter. What is 2 times a quarter?
Half.
There you go.
No, you wouldn't have. Why would you have 2 times a quarter? Where'd the 2 come from?
You have to factorize it out, don't you? Hold on.
You'd have a quarter times a half, which doesn't work.
They
I have no.
They did something magic because it's in a square root. Let's see what magic they did here.
Half. That's what we got. Yeah.
So they did.
I don't know what that's meant to be.
I know what they did.
They took out a quarter, but then they added it over 2.
What did they do that to me? They did the whole thing over root 4.
Huh?
So.
What?
Yeah. Why would you make it so difficult? Okay. I
It
think.
is 6 marks, but it's confusing even for a 6 marker.
And so this one here, that is the same as the square root of 4 over 4 minus x squared over 4,
Yeah,
which is the same as the square root of 4 minus x squared
the whole thing over 4.
over 4, which
That that's
which is the same as the square root of 4 minus x squared over the square root of 4,
yeah.
which is, and the square root of 4 is 2.
Okay. That kind of makes sense. But you know how they put 4 minus x squared? Couldn't you just factorize that?
You know the way they did what, sorry?
The way it's like square root of 4 minus x squared. Can't you just factorize the 4 minus x squared? Because it's the difference of two squares.
You can, well, they gave us 4 minus x squared. We didn't actually get it.
Okay. Yeah, that's
The,
true.
I
But,
noticed it was difference of two squares here, but the problem is you can't square root the difference of two squares.
that's true. Okay.
So if anything, we tried to put it into completed square form. Okay, and then we get that. What was it? Was there anything else? Yes, x is between what and what. I think you're okay for that part.
Yeah, I kind of know how to do it.
Yeah. Okay. Any questions about that?
No, it's just really confusing. But
Agreed.
I don't
Let's see.
do that.
This is a mixture of cot
So,
and sine.
oh wow.
This
Okay.
might be similar to the tricky one from before. Let's try to do this.
So it's x is equal to 3 cos squared 2t over sine squared 2t.
Yeah.
And then you have, oh, that's easy. That's really easy. This one's easy.
It is.
Yeah. Because y is equal to 3 sine squared 2t. Oh, you shouldn't do x. Oh,
I shouldn't. I don't know.
where would the 3 go? If you had, would you just have 3 times cos squared? Okay, never mind. I'm confusing myself. But it's still easy.
I'm glad you
Because
find it
y
easy.
over 3 is equal to sine squared 2t.
Right.
So, yeah. So x over 3 is equal to cos squared 2t over y over 3. I don't know how you do that, but
Keep change flip. So that's going to be the same as 3 cos squared t over y.
okay. That's it. Is that solved enough? Like, is that a Cartesian equation, or do you have to do more? Oh, you have to get rid of the t. Oh, well, cos squared t is just 1 minus y over 3.
Cos squared t is
Actually, how did it become t instead of 2t? It should be 2t, I'm pretty sure.
3. That should be 2t. Yeah, that should be 2t. Yeah.
Everything just became t somehow. But yeah, it's still 1 minus y over 3.
Okay. Does that look like what you said?
No?
You. Okay, let's see.
Yeah, it does, I think. I think if you did y is 1 minus cos. Wait. Okay, no. It does not look like that.
Chicken does, man. Let's see. So cos squared 2t. Cos squared 2t is the same as 1 minus sine squared 2t.
Mm-hmm.
which is the same as 1 minus y over 3.
Yeah.
So x over 3 is equal to 3 over y times 1 minus y over 3.
Mm-hmm.
So that's kind of done, but they just want you to make y the subject.
Oh. Multiply the bracket out.
Mm-hmm.
So then you have 3 minus y on the top. Oh, yeah, or just 3 minus y in bracket. Or not in brackets. Wait, why did you do 3 over y? There would be a y on the top in the numerator as well. Because when you do 3 times y over 3.
I don't know. 3 over y times 1. 3 over y. And then
Oh,
3.
that would just be minus 1. Yeah. So it cancels out. Is equal to x over 3.
Mm-hmm.
Not really sure what you do next.
Oh, that's the easy peasy bit. So it's going to be x over 3 plus 1 equals 3 over y.
Yeah.
Times both sides by y.
It's O and then divide by x over 3 plus 1.
Yeah.
Then how did they get like some weird...
They made it look different. So we've got a fraction of a fraction.
Yeah.
But we made y the subject. Y equals... you can simplify it down to 9 over x plus 3 by multiplying everything by stuff.
Okay.
Yeah, you could multiply the top and bottom.
By 3, I think. Yeah. If we did that, we would have the same answer.
Yep. And then the domain. Fair enough. Any questions there?
I mean, it was a bit hard, but...
Well, it was a bit 6 marks.
Not that bad.
Hang on. So, hold on. So you found that one hard. I thought that was a pretty easy one. Let's see.
It's not that bad. Like, I understand it, but it was like a bit hard.
I think the key is here. Sine squared t is equal to y over 3, because then the other one, when you have cos squared 2t, that's the same as 1 minus sine squared 2t. And you can go from there. This one is a mixture of cot squared t and cos. Is this worth doing?
X equals cos squared t over sine squared t. 3 equals.
Let me think about this. Yeah, that'll work. I just want to see something. So what was our cot one again? 1 plus cot squared x equals sec squared x, is it?
Cosec squared x.
Cosec. Yeah, you're right, but that's not...
You can just square.
Yeah, we'll do it that way then. So cos squared t over sine squared t. Okay.
And then you can just square the second one. So you have y squared over 9 is equal to cos squared t.
Yeah.
And then you can just substitute y squared over 9.
So I'm just going to write x minus 3 times sine squared t.
Yeah.
Is equal to y squared over 9.
And then that sine squared t, you can do 1 minus y squared over 9.
And that is the same as, so cos squared is 1 minus sine squared t. So if you put that there, that's going to be the same as x minus 3, 1 minus y squared over 9 equals y squared over 9. And you want to make y the subject?
Yeah. Expand the brackets.
Suppose we have to. Do you think you'd be able to do it, or?
Yeah, I can expand that.
No, like, do you think you'll get it right, or you want to try it?
I think I know how to do it from there.
See, I think once you get them together, that's the easy bit.
Yeah, it's just expanding and rearranging.
Okay, so you expand, you rearrange, and you get, at some point you'll get y squared equals, and then you'll just square root both sides.
Perfect.
Any questions there?
No.
That's all right. Whoops. Let's see, is this any different?
Oh, they're both sine, but there's sine 3t. I don't know what that.
Okay, any idea how you do that one then?
No.
I know how.
Sine 3t is sine 2t plus t.
Sure is.
And then you do the addition formula.
Do you know what it is?
Sine 2t, cos t.
Yeah.
Plus cos 2t sine t.
Mm-hmm.
And then, 3x is equal to sine t. So you can just do sine 2t cos t. So you can just substitute 3x basically.
For what?
Sine t.
So this would be 3x over here?
Yeah.
What is sine 2t the same as?
Sine t plus t.
And if you were to expand that out, it would simplify down to 2 sine t cos t.
It's t. Or cos squared t. But
Yeah, so that'll be cos squared t. That gives me a bit of space. What about cos 2t?
that simplifies to 1 minus 2 sine squared t.
1 minus 2 sine squared
You can basically just substitute everything.
Whoa, what do you have to substitute where?
So the 2 sine t would just be 6x.
So this one will be, I'm just going to go right back to the start. So that's going to be 2 times 3x cos squared t.
1 minus 3x squared. The whole squared.
3x squared.
Yeah. And that one's already done. Oh wait, 1 minus 2 sine squared t. 1 minus 2 times 3x the whole squared. And yeah, and then 3x. And then expand everything.
Technically, hold on.
Maybe
wanted it fully
you don't need to
factorized.
expand it. I think, I'm not sure if you need to, but I don't know.
They wanted it to look like this. We have to basically fully factorize. So maybe it does help. That would be 6x. 1 minus 9x squared.
Yeah, I think you can take out 1 minus 9x squared, and then but the second one's a problem because there's 2 times 9x squared.
Nothing wrong with that. Let's see. So the second one is going to be 3x 1 minus 18 x squared. Which is the same as 1. Now, you can factorize.
How?
I believe they both have 3x in common.
Yeah, that's it. So 2, 1 minus 9 x squared plus 1 minus 18 x squared.
Minus 18x squared. And then we simplify. Hang on. Will you simplify that?
2 minus 18x squared plus 1 minus 18x squared, which gives you 3 minus 36x squared.
So that gives, we have 3x, 3 minus 36x squared.
Yeah.
Can we simplify it further?
Divide by, take out 3, I suppose. Yeah.
12x squared?
Yeah.
I think that's it.
That was long. What?
9 and 12.
Okay.
There we go. 9x, 1 minus 12, x squared. And I think other than that, it's all the same. Yeah, any questions there?
No.
That's all right. Okay, is this any different? Is it worth doing? It's similar to what we did before. Is it worth doing?
I don't know. It looks the same as that, really.
It's the same addition angle formula, and then you go through. It looks very, yeah. You've got a quarter on the outside.
It literally looks the same.
Yeah. And it's got a worked solution, so that's all right. This one, tan squared sine squared. This one they asked for y squared equals, so that'll be okay.
Yeah, that's pretty easy.
Yeah, if it's got y squared equals, you just make y squared the subject. Let's see, this one looks very similar. It's a addition angle formula. That's okay. Okay, using trig identities.
I think it's like in between the half and the tick. Just because I don't really know the trig identities, so I probably should learn them.
Which trig identities do you not know?
Any.
So I can never remember them. So I just do sine squared x plus cos squared x equals 1. And then you can just divide everything by sine squared x or divide everything by cos squared x.
Okay.
And then you can get the...
Is there an identity that's like tan squared x?
Yeah. So what is tan the same as?
Tan. Oh, sine over cos.
And so...
Because if you divide everything by cos squared, you'd have tan squared.
Yeah. Squared x is 1. So to make tan, you have to divide by cos squared. What do you get?
It's tan and cot then.
Yeah.
That's tan squared x plus 1 is equal to cosec.
Sec squared x.
Oh, sec. I always get confused between them.
Look, it's always the third letter.
Yeah.
Yeah. So, and there's more sketching curves. Yeah, we did that a lot for parametrics. Just want to see what we didn't do is parametric differentiation, but that's very, very easy. It's like because they're different, because they're separated. You literally just do the derivative of the y over the derivative of x. So it would just be, let me just go way back.
We should never learn that. I didn't even know we need to know how to differentiate. parametrics.
I think you do. But this one, the derivative of this one, the derivative of y over the derivative of x. So it would be 2t over 2.
2. So that's just t.
Yeah. And because they're separated out, it's quite easy. So
Okay.
any idea what you want to do next time?
Not sure.
Yeah, you can let me know, or I can pick parametrics. Oh, points of intersection. Oh, okay, so you'd have to actually say, like, find where they cross over with each other. Like, it's like simultaneous equations with parametrics.
What's that modeling with parametric equations bit?
That is applying it to the real world, and so
Odd. Or
we could do that. So 8.5. So hang on. So simultaneous equations with parametrics is just where they cross over, finding points of intersection, and then modeling is modeling it to the real world. So
I think I'm going to need to do that.
okay.
It looks
8.5. Any questions for me in general? All right. Well done, Amogha. You did great, and I look forward to chatting again next week.
Bye.
Have a good week. Goodbye.